So this video continues Chapter 6 of Geometry, specifically 6.5 and 6.6. So by the end of this video, you should know a ton of new conjectures that are super useful to know about parallelograms. So what is a parallelogram? We've covered it before, but in case you don't remember, a parallelogram is a quadrilateral whose opposite sides are parallel. So we have two pairs of parallel sides here. So now we're going to start our list of conjectures. So the opposite angles of a parallelogram are congruent. So that's pretty clear. So if we have these parallel sides, then with that is going to come congruent angles here and here, and then here and here. And then the consecutive angles of a parallelogram are supplementary. That's also pretty clear. Say if we extended these lines here, then you could see that we have something like that we've covered before, which is like a transversal and two parallel lines. So these consecutive angles are going to be supplementary, just as they would be if it wasn't actually a parallelogram. Like say we just ignored this side. We know this from earlier chapters. Another conjecture, which is super useful to know, is that the opposite sides of a parallelogram are going to be congruent. So as well as being parallel, they're also going to be congruent. And then the diagonals of a parallelogram bisect each other. So if we draw in some diagonals here and here, you can see that this is going to be congruent to this, and this is going to be congruent to this. Okay, so this is somewhat related, really important though. So we're going to talk about vectors. So vectors are quantities. So a vector is a quantity that has both direction and magnitude, and it's represented as arrows. So then a resultant vector, or a vector sum, is the single vector that has the same effect as two vectors. And a way to draw a resultant vector is to line the two vectors, the two beginning vectors, up tail to tail, and then complete a parallelogram with them, using them as the sides, and then the resultant vector is going to be the diagonal from the tails. So here we have the resulting vector from these two beginning vectors. So now we're going to move on to properties of special parallelograms. These are figures such as rhombuses, squares, rectangles. So our first one, it sounds kind of weird when you say it first, but it makes a lot of sense otherwise. So if two parallel lines are intersected by a second pair of parallel lines the same distance apart as the first pair, then the parallelogram formed is a rhombus. So the best way to explain this one is just to draw it. So if we have two parallel lines here, and they're about this far apart, and then we have a second pair here, and they're going to be just about the same distance apart, hopefully. And so these two are parallel, and then these are parallel. Then this figure formed here is not only going to be a parallelogram, it's also going to be a rhombus. So it's going to have all congruent sides. So now we're going to talk about rhombuses for a bit. So our first conjecture is, so the diagonals of a rhombus are perpendicular bisectors of each other. So here let's draw in the diagonals. So we can see that they're going to be perpendicular to each other, and also that they're going to bisect each other. And then Another thing, the diagonals of a rhombus bisect the angles of the rhombus. So you can see here, my picture isn't great, but you can see that these angles are going to be just about congruent. And that's another conjecture about rhombuses. Okay, now we're going to move on and talk about rectangles. So this conjecture might seem pretty clear. The measure of each angle of a rectangle is 90 degrees. We know that from our definition of a rectangle. They have 4 right angles. And then the diagonals of a rectangle are congruent and bisect each other. So we have here a diagonal and here a diagonal, and they're congruent, and they bisect each other, so they're going to form 4 equal segments here. So there are actually a lot of ways to define what a square is. We could say that it's an equiangular rhombus, because a rhombus has all equal sides, but if we define that as equiangular, then that's a square. Or we could say it's an equilateral rectangle. So we know that a rectangle has all right angles, but we don't necessarily know that it's equilateral, but if it is, then it's a square. So again, we know that it has all right angles, and then if we limit the sides to being congruent, then it's a square.